I want to take a look at this animation. It's a classic shader animation that uses the Sine function to create a wave pattern. I think it's a great introduction if it's your first shader. And I'm going to bring this animation to the next level by adding some scroll interactivity on top of it. And that way we can truly understand everything that's happening. So I'm going to use a bunch of different libraries to make this. And as always, you can find the live demo and the source code in the description if you're interested. All right, so I have a very basic Next.js application here, and I've deleted everything inside of it just to start with a nice blank application. And also I've installed all the different libraries already that I'm going to use to make this animation. I have React 3.js, React 3 Fiber, Firmotion, and the Leva library. So using those 4 libraries, I'm going to make this animation. So now, the first thing that I'm going to do here is create a bunch of external components just to have a nice organization among my app. So the first thing I'll do here is create a components folder. And inside of it, I'm going to have a scene.jsx and I'm going to have a model.jsx. I'm going to start with those 2 for now. And I'm going to have here my scene is going to be a basic React component. And it's inside of that scene that I'm going to return the React 3 Fiber canvas. And so here, instead of returning a div, I'm going to return a canvas. And inside of that canvas here, I'm going to return the model, which is going to be that other external component that I've just created. So it's going to be this one here, and this one is going to be another React component. And now since that model component is inside the canvas context, I can't return a div here. It doesn't make sense. And so I'm going to return here a simple group that's going to act as a div. So here I'm importing the model component. And now I can go back inside of the page.js and import that scene component. And the way I'm going to do this is by using the dynamic import by Next.js. If you're not using Next.js, don't worry about this. This is simply to force a client-side rendering of this component. Since it's a canvas, I don't want to render it on the server. And so if you don't use a server-side framework, then don't worry about this. So I'm going to import the dynamic from Next dynamic here. And then I can have my scene, which is going to be equal to a dynamic import. And here I'm going to do an import, and I'm going to import my scene. And I'm just going to add a parameter to do SSR false. And that's basically saying no server-side rendering for this component here. And now I can put it here. And now Next.js is going to complain. So all I have to do is specify that this is a client component. So I do use client here. And in my opinion, the main advantage of using that dynamic import for our main scene is we can actually return a placeholder while the scene is loading. Now, I'm not going to do that for this tutorial because it's a bit irrelevant, but in a production application, it's quite interesting to use that concept. So with that, I have my basic setup. I have my scene imported inside of the page.js, and inside of my scene, I have my model. And so now I can go here inside of my model, and here I'm going to create my plane. All right, that's the first thing that I'm going to do. I'm just going to create a basic plane. So for that, I'm going to remove the group, and instead I'm going to return a mesh. Very simple like that. And the mesh inside of it, I'm going to specify its geometry or like its topology, and it's going to be a plane geometry. And here that plane geometry requires a couple of arguments. The first 2 inside of the array is the width and the height. And so it's going to be 3 by 3. And then the 2 other arguments are the number of vertices inside of the plane. And so I'm going to do 15 by 15 for now. And I'm eventually going to add the wireframes. So you're going to see actually what all of this is about. And then once I have my geometry, what I need now is a material. So here I'm just going to create a mesh basic material. And here I can just add a simple color. I'm going to do red. And if I save that, you're going to see that I have a small little square here. And now it's really small actually because my canvas, if I inspect it, my canvas is really small, right? It's just taking a height of 150 pixels. And so it's not taking the full height of the screen. So to fix that, it's going to be quite simple. I'm going to go back inside of my page.js. And here I'm simply going to specify that this should be height screen. So 100 viewport height for the main div. And now the scene, which has the canvas inside of it, will automatically take the full height. And so with that, we have a nice square taking the full screen, and it's also responsive if I move the window around like this. And now I'm going to add a wireframe true, and here we can see the wireframe of the plane. And if I change here, you're going to see if I change the number of vertices, if I do 35 by 35, you're going to see that I have a more detailed plane, and that's quite useful when I'm going to do the wave later on. I'm going to move the vertices around, and so having a bunch of them is actually useful to have a smooth wave, right? If I don't have a lot of them like this, the wave will be quite like tacky, right? It will be edgy. But for now, we're just going to leave it at 15. Okay, now that we have a plane, we can start having fun and start deforming it in the shape of a wave. And so to do that, we need to understand a couple of things. And so the first thing we need to understand is like the characteristics of a wave, or like the anatomy of a wave, if you will. So two things that we need to understand that we're going to play with in this animation. The first thing is the wavelength. And so that's basically the spacing between different waves. And the second thing is the amplitude, which is basically the height of the waves, all right? Those are the two parameters that we're gonna play in this animation to create a wave effect. And the other thing that we need to understand is the sine function. So it's used a lot in animation in general. So if you don't understand it, now is a good time to understand what's happening. Really, the most important thing to remember about this function is that it always returns a value between -1 and 1. And so we can use it to create a wave pattern. It might seem a bit counterintuitive, but you'll see it's actually quite amazing. And so we can create this wave pattern by giving it a continual value. For example, it could be 1, 2, 3, 4, 5, right? In an interval, and it's always going to return us this wave pattern because it always returns us a value between -1 and 1. And so I don't want to spend too much time in the theory. You're going to see in the practice is going to make a lot more sense. So like I said, I'm going to play with two parameters of the wave, the amplitude and the wavelength. And so for that, I'm going to use now the Leva library just to have a GUI so we can modify them in the browser to see like the different effect of changing those parameters. So for that here, I'm going to have my amplitude and my wavelength, which is going to be equal to the use controls from the Leva library. And here it's going to be an object. And inside of it, I'm going to have my amplitude and it's going to have a value. I'm just going to do 0 for now. I can give it a min of 0, a max of maybe 5, and a step of like 0.1. And I'm going to copy paste that and do the wavelength. Now the max is going to be 20 and it's going to step by 1 at a time. So we can save that. And you're going to see that now I have a GUI and I can modify the amplitude and the wavelength. And that's just a more convenient way of changing those parameters instead of just changing like the numbers here every time, right? So now how can I use those values, the amplitude and the wavelength, to change the different vertices of that plane? Well, for that, I'm going to have to create a shader, all right? I cannot change the different vertices using a mesh basic material here. I'm going to use a shader. It's going to be much easier to do. So I'm going to start by recreating that mesh basic material, this effect that I have here, but using a shader. So instead of having a mesh basic material, what I'm going to have is a shader material here. And inside of it, it requires a couple of things. The first thing is the vertex shader, and it also requires the fragment shader. So very quickly, the vertex shaders dictates the different position of the vertices, and the fragment shader determines the color. All right, that's in a nutshell. And so now I need to create those different shaders. So I'm going to go inside of my components and I'm going to do a shader.js. And here I can export a const vertex, and it's going to be equal to some GLSL code. So the first thing a vertex shader needs is a void main function. And here it needs to return a GL position. It needs to be equal to something. But first, what I'm going to do is I'm going to do a new position. And here it's going to be equal to the current position of the vertices that I'm in. And so this code will run for every single vertices. And so this position is an abstract representation of the position of every single vertices, right? I hope that makes sense. And so here I'm just creating a copy of that position, and I'm going to modify that new position eventually to create the wave pattern. And now for my GL position, I'm just going to return the basic parameters or the basic pattern of a vertex shader. This is just going to return my mesh as is, so with no modification. And to do that, I'm just doing the projection matrix multiplied by the model view matrix multiplied by the position of the current vertex. And so now that I have that, I need to also export a fragment shader. It's also going to have a main function. Now this time, instead of returning a GL position, I'm going to return a GL frag color. And now I'm going to return the red color just to recreate this mesh basic material. And so to have the red color, I'm just going to do vector 4, 1, 0, 0, and 1. That's like the RGBA of the red color, right? Now I'm going to save this. And here I'm going back in the model, and I'm going to import here my fragment shader, and my vertex shader. I'm importing that from the shader file that I've just created, passing the fragment to the fragment and the vertex to the vertex. And I'm going to save that, see what we have. And I don't see anything. That means I have an error here. And I believe it's very strict. So I just need to add this right here, and this should unlock everything. I'm going to save. Yeah, and now we see I have my plane with a red color. And if I want my wireframe back, all I have to do is do wireframe is equal to true. And with that, I'm back with what I had before, but now I'm in a custom shader material. And with that, I can go inside of it. And in my vertex shader, I can start playing with the position here and create a wave pattern. And like I said, to create that wave pattern, I need my amplitude and my wavelength. So now, how do I pass those two values to the shader material so that I can use those variables inside of the code here? Well, for that, I'm going to use what we call uniforms. So what I'm going to do is create a uniforms const. It's going to be a reference. And so if the state of my component changes, it's not going to reset my uniforms, right? That's why I put it inside of a ref. And here I'm going to have my U amplitude. I'm adding U before. It's kind of a convention inside WebGL just to specify that this is a uniform. And it's going to have a value, which is going to be equal to the amplitude. And then I'm going to have my U wavelength value of the wavelength, right? I'm taking those two values that are defined inside of my controls. And now to give the uniforms to the shader, I'm just going to do uniforms is equal to uniforms. Simple as that. And now we can have some fun. And I now have access to my uniform by doing uniform float. And here I have my U amplitude and I have my uniform float U wavelength. And what I have in mind is to start modifying the position of each vertices. So for example, I could do, for example, on the X, I could do plus equal 0.1, for example. And if I save that, okay, I'm going to do a bit more, maybe 1. And now you see that all of my vertices are now moved on the X-axis by 1 point, right? And if I do minus equal 1, it's going to go on the other side, right? That's a bit of the concept. But instead, what I'll do is change on the Z-axis. So now if I do minus equal 1, we're just seeing the same thing, right? Because the Z-axis is this line here. So if I move it forward or backwards, we're not going to see the difference. But if I have one vertices that's closer to me in relation to the other, then I'm going to see a difference, right? But if I move all of them at the same time, obviously I'm not seeing any difference. So here's where the sine function comes into play. So what I'll do here is have a float wave, and that's going to be equal to the sine function. And if we remember correctly, the sine function always return -1 or 1. So what I could do as a parameter is give it the X position. And so depending on the X position of each vertices, the sine function will return us a different value, and it's going to be in a wave pattern. So I'm going to grab my new position. On the Z, I'm going to do plus equal the wave. So I'm going to save that. And here we kind of have a wave, right? Which is pretty nice. And I could have fun and start multiplying stuff. And I could do multiply by 2. And you're going to see that now my wave is changing. I could multiply it by a crazy number. And you're going to see that it's kind of looking different, right? And if you're seeing the pattern here, the lower the number, the longer the space between the waves, right? If I do 1, the wave is really long. If I do 2, the space between each waves is getting shorter and shorter, right? So that's where I'll put my U wavelength right there. And if I do that and I go here, you're going to see that I lost my wave. And that's because my U wavelength is initialized at 0. And so now it's just doing sine of 0, which is 0. And even if I change my wavelength here, the value, it's not doing anything. And the reason why is it's not dynamic, right? So even if I change those values here, the values inside the uniforms is not updated. And so to update them dynamically, what I'll do is use the use frame, which is a function that runs at every single frame. And by the way, it comes from React 3 Fiber. And it's inside of that I can now update the uniforms of my mesh. And to do that, I also need to create a reference to target it. So here I could call it my plane. And so const plane is equal to use ref. And then I could do plane dot current. And I'm going to target the material dot uniforms. I'm going to grab my U wavelength. And I'm going to make it equal to the wavelength, which is the value here that comes from the controls. I'm going to save that. And it's giving me an error. Cannot set properties of undefined. Okay, to fix that, I have a typo here, uniforms. And I also need to specify the value here, the value, right, of the U wavelength. And I'm going to save that. And I still have an error here. I believe I need to specify current in my uniforms because my uniforms is a ref. And so that should make sense. Okay, and now it works. And if I change my values here to like 2, yeah, this seems to work. Okay, so now what I'll do is set the default value of my wavelength to 1. And I'm going to grab the wavelength here inside of my use frame. And so now if I change this, Nice. Now I can dynamically change the length of my wave, and you're going to see the higher the number, the shorter the space between each waves, right? That's kind of it. And now I'm going to do the same thing for the amplitude so I can use it inside of the shader. So I'm just going to copy paste that. I'm going to do u amplitude is equal to the amplitude. Simple as that. So now where am I going to use my u amplitude inside of that sine function? Well, actually, I'm going to use it outside of it, right? I'm just going to do, just for fun, I'm going to do multiplied by 2, right? Multiply everything by 2. You're going to see that it gets a bit more intense, right? If I do multiply by 3, even more intense, right? And if I do it on the other side, maybe multiply by 0.5, it gets less intense. So that's basically where I'm going to put my u amplitude. And so this is going to change the height of my wave. So I'm going to put it here, save that. And now my u amplitude, I'm going to give it a default value. Now I'm going to do 0.25. And I'm going to change the step to 0.05 and keep the max at 5. So let's see what we have. I'm going to change my amplitude, and you see that here it changes the height of the wave, and I can change my wavelength as well. So now I kind of have a control, and if I find the right values, I can potentially create a wave pattern here, something like this. So I'm going to do 0.25 and 5. This is kind of a decent wave to me. As a default value, I'm going to do 5 and 0.25 like this. And if I want my wave to be a bit smoother, because it's a bit like tacky right now, it's a bit of too many angles, right? I'm just going to change the number of vertices here to maybe 45 by 45. And here you see that my wave is much smoother. And if I change those values, you're going to see that it's a bit more smooth, right? And so now that I have this wave, I need to find a way to animate it, right? To make the wave go in a continuous motion. Because right now, it's just a wave, but it's not moving. So it's really simple to do that. All I have to do is create a time value that I'm going to increase at every single frame. I'm going to pass it to the shader, and I'm going to put it inside of the sine function. So like we did before, add a time uniform value of 0. Inside of my use frame, I'm going to increment that u time, and I'm going to do plus equal. And here I could have a speed. I'm going to do 0.04. And now I have my u time as a uniform. So I'm going to uniform float u time. And here I can grab my time, and I can simply add it as an addition inside of my sine function here. And the logic of adding the time inside of the sine function, if we take a look back at the sine here, all I'm going to do is increment at every single frame that value. And so the wave will kind of advance, right? It will kind of move forward by always having an increasing value. So I'm going to save that. And now you can see that I have a nice wave in a continuous motion, and I could change that speed, right, by changing that time value. And I could have maybe 0.01, so that would be a slower wave, or I could have 0.1 for a faster wave, right? But for me, 0.04 is a good number. And here I could change my wavelength, and I could go crazy with it. And honestly, I think the amplitude is getting too crazy, like very fast. So I'm going to put a max of 2 here. It's a bit of a nicer control. And now this is also a nice wave. You know, you could play around in tune to have your own wave. But to me, this is pretty good. So now we have our wave. I'm going to go to the second step of this tutorial, and it's to add an image on top of that. Because now it's a bit boring. All it is a plane. And I could also remove the wireframe just for fun. We would just have this, right? Which is a bit boring. Now I want to add an image on top of that. So I have my image here inside of my public folder. I'm going to have my images component. I'm just going to grab that image, maybe do like a copy paste. And here I have the image that I want to use. So now to transform my image into a texture that I can use inside of Three.js, what I'm going to do is have here a const texture. It's going to be equal to the use texture hook from React 3.js. And here I can just go and find my image. It's going to be in the images car.jpg. And now I have a texture. Nice. And now I need to pass that texture to my shader. And inside of my shader, I'm going to have my fragment. And inside of my fragment, instead of returning a red color, I'm going to return the texture. So to do that, same thing that we did before. Another uniform, but it's going to be u texture. And here the value is going to be the texture. And now inside of the fragment, I have my uniform U texture, and the type is not a float, right? It's going to be a sampler 2D. And here I can have my vec4, and I could call it color is equal to a texture 2D, and that's like a basic function inside of GLSL, and it's gonna grab the U texture, and inside of it I'll also need to pass it the UVs of the texture, and I'm gonna have the VUV, but unfortunately I do not have access to the VUV inside of the fragment, but I do have access to them inside of the vertex. And so to pass it from the vertex to the fragment, I'm gonna have a varying, and I'm gonna call it the VUV, and it's a vec2, and here I can do VUV is equal to the UVs, right? And the UVs is a bit like the position. I have access to them by default. And so now I'm going to grab, and so now I have my varying here, putting it here, I have access to it, and I can create my color, which is a texture 2D using the texture of my image and the VUV that comes from my vertex. And instead of returning a red color, I'm just going to return the color here. And if I save that, I now have my image. Now, of course, it's a bit weird because I have my wireframe set to true. So I'm just going to toggle it to false. And now it's nice. I have my image. But if you have a good eye, you'll see that it's actually distorted. Like even if I turn off everything, you'll see that it's stretched, right? My image is not the right aspect ratio. And that's because my plane is square, but my image is in portrait mode, right? It's in portrait. And so because of that, it's distorted. So I need to find a way to fix that. And there's actually one really nice hook created by React 3.js, created by the community, and it's called the use aspect. So I'm going to use that use aspect right now. It's going to return me a scale, and that's going to be equal to the use aspect. And this use aspect hook is actually used to create, if you know the CSS cover property in CSS, right? When you do like background image cover, it's kind of trying to replicate that, but for Three.js. So it's actually really useful. And so here I'm doing the use aspect, and it requires a width and a height and a factor, right? So my width and my height, I can grab it from my texture. I can have width and height coming from the texture. So really nice. And so now I can give to that use aspect the width, the height, and I can give it a factor. If I give it factor 1, which is the default, the scale here is going to be full screen. So you're going to see I'm going to do args 1 and 1, and I'm going to change the scaling to be the scaling that comes from my use aspect, right? So 1 and 1 is going to take exactly the scale here, right? 1 multiplied by the scale. And you're going to see, I believe that's going to create a full screen mesh, right? With the image as a texture. So I'm going to save that, and nothing is happening. Something is wrong. I think my texture here, I need to specify the image inside. So that's the width and the height of the image of the texture. I think that's just something I need to specify. And yeah, with that, I'm just going to turn off the wave. And you see, if I keep a factor of 1, it's creating me a full screen image, and it's actually super responsive. So that's a super nice hook from the community. And here I'm just going to reduce that factor to maybe 0.3 to have something like this. And so with that, I have a nice wave on a plane with an image. So that's kind of the effect that I wanted to go for. And if I move my window, you're going to see that it's actually responsive, and I can change the length of the wave. I can change the amplitude, and I can go pretty crazy with this and have a super nice effect. But now that we have this, I want to bring the animation to a next level. And you're going to see just by scaling the image on scroll, it's going to add like a crazy level of complexity. And you're going to have to understand like how to scale UVs, how to scale the plane dynamically and all of that. So I want to get into this right now. So for that, the first thing I want to do is create a sticky section. So as you may know, in a lot of my tutorials, I use a combination of a sticky section and the use scroll hook from frame of motion. So I'm going to use the same concept here. I'm going to go back inside of the page.js, and here I'm going to change a bit. My main is going to have a height of 300 viewport height, and inside of it, I'm going to have another div, and I'm going to give that div a height of 100 viewport height. And it's also going to be sticky with a top 0. And I'm going to put the scene inside of it. And I'm going to create another div just as like a padding thing. And I'm going to have it take 100 viewport height. Simple as that. I'm going to save that and see what we have. I should have a sticky section now. Okay, it's not working. It's sticky all the way through. I believe I have one level. Yeah, I need to create another level here of div. The styling to that div like this. And also move this guy outside here, and this should work. Nice. So now I have a sticky section for 300 viewport height, and at the end here, it unsticks. So that's pretty good. And now what I want to do is scale that image on scroll, something a bit similar to what I have on my blog here. You're going to see the demo I have here. And when I scroll, it's going to scale up. It's going to reduce the wave slowly to a null point. So it's going to not be wavy at the end. And then here it unsticks, right? So I want to create something like this. So I have my sticky, pretty good. And now I need to track when it's sticky and when it's not sticky, so I can have a value, so I can modify the scaling of the plane and the amplitude as well. So to do that, I'm going to use the use scroll hook from frame of motion. So here I'm going to have, coming from the hook, the scroll y progress. It's going to be equal to the use scroll hook. And here I can have a target. It's going to have a container. It's going to be a ref. So here I'm creating the container is equal to the use ref hook. And I'm putting that ref to the container that's 300 viewport height. And here I can also add an offset. And so when do I want to start and stop the tracking? So I want to start the tracking right away. And so it's going to be start of the window, and start of the container. So start. That's when I want to start tracking. And when do I want to stop tracking? It's going to be at this point here. And so this is the end of the container and also the end of the window, this point here. So end. Okay, it's not happy. Okay, there was a conflict here. The use scroll, it thought it would come from React 3.js, but it comes from frame of motion. So VS Code got a bit confused here. And yeah, now it's working fine. So my scroll y progress is now a value between 0 and 1. 0 starting at first, and then it's going to be 1 when I'm at the end here. So now I have a value to track the progress of the scroll. So I'm going to pass down that value, kind of do like a waterfall or like a trickle down of props. I'm going to give the scroll progress to the scene here. And I'm going to go inside of my scene. Here I have my scroll progress, and I'm going to give it to the model here. Go into the model, and now I have access to my scroll progress. And now I can use that scroll progress here to start modifying things. So the first thing I could do here, really simple, is slowly reduce the amplitude to a null point. So similar to what I have in my demo, the more I scroll, the less amplitude it has, right? It's kind of slowly going to 0, right? So this is what I want to create at first. And so to do that, instead of my use frame loop, what I'm going to have is a modified amplitude. So I'm going to have a modified amplitude, and that's going to be equal to the transform function of frame of motion. It's kind of similar to the use transform hook of frame of motion, but instead it's just like the method that I can use inside of another hook. And so here I'm going to create a transformation that's going to be based on the scroll progress. And I know it's a value between 0 and 1. And my end result, what I want to have here as my modified amplitude, it's going to be at first, it's going to be when the scroll progress is equal to 0, then I want it to take the amplitude value inside of my use control. And when the scroll progress is at 1, meaning when I'm all the way at the end here, I want my amplitude to be 0. And so now I have a modified amplitude that's based on the progress of the scroll. So now I can use that and give it to the amplitude uniforms. I'm going to save that, see if that works. Now I have an error. And the reason is my scroll progress, which is defined inside of my page.js here. Here, it's actually a motion value of a number, right? It's not a straight number. So if I put it inside of my transform hook, it just doesn't understand what's going on. So what I need to do is do a get. And so that's going to return me the number. It's going to return me like the int, right? I'm going to save that. I'm scrolling right at the top. My amplitudes should be 0.25. And if I scroll, it should reduce gradually towards 0. And here, you're going to see that my amplitude is reduced to 0. So that's really nice. I'm going to make it even crazier. So have like a crazy high amplitude. And as I scroll, it's slowly reducing towards 0. So that's pretty cool. Now, the other step is to scale the plane towards full screen, right? So I'm going to use the same concept here, but I'm going to do it for the scale on the x-axis and the scale on the y-axis. So I'm going to create this. I'm going to have scale x and scale y. And so I'm basing it on the progress of the scroll. It's a value between 0 and 1. initially, what should the scale x be? Well, I'm going to take the scale that I've defined inside of my mesh here. And to have access to the x-axis, I have simply to take the first elements of that scale. And same thing for the y, but it's going to be the second one, right? So I have xy, scale x, scale y, the initial one that I've set for the mesh. And I could scale it towards 0. Let's keep it at that for fun. And to apply my scale, all I have to do really is do plane.current.scale.x is equal to scale x. Plane.current.scale.y is equal to scale y, right? Something like that. And so now it should be scaling down to 0 as I scroll. So yeah, it's just disappearing like this. Pretty cool, but it's not really what I want, even though this is like a proof of concept that what we're doing is working. But now instead of scaling it towards 0, I want to scale it to full screen. So how can I get the values here of the full screen? Well, what I could do is grab the viewport from the use3 hook. This is a hook from React 3 Fiber, and it returns us a bunch of things inside of it. Basically has the state of the WebGL context. And inside of that state, it has a bunch of things. And one thing is the viewport. And that viewport has a bunch of different properties, as you can see here. But what we're gonna do is use the size. So all I have to do is target viewport.width and viewport.height. And so that's basically the full screen, right? So I'm gonna save that. And here I'm gonna scroll. And now it's getting towards the full screen. So that's really nice. It's working good. And if I change the size of my window just for fun, so I have my plane here, I'm scrolling and it gets to full screen, which is really nice. And if I put it like mobile, is it still working? Yes, it is. But now you're probably cringing if you have a good eye, because as you can see, the texture is just getting stretched bad, right? So obviously this is not useful. This is just not usable in a real world context. So the reason is we're scaling the plane, right? And so we need to also scale the UVs of the plane so the texture does not get stretched. So that's where we get a bit into the rabbit hole of doing 3D on the web, all right? Kind of have to take a lot of things into consideration. So let's see how we can do this. Same thing as before. If I want to modify my UVs, I need to do it inside of the shader. So to do that, I need to create a uniform. So I'm going to create another uniform and I'm going to call it UV scale. But honestly, it's a bit of a nightmare with the U in front of it. So I'm just going to call it VUV scale like this. Even though I'm breaking my convention, it's just like burning my eyes. So I'm just going to keep it at this for now. And for the value, I'm going to create a vector2. So I'm going to create a 3.vector2 0 0. And now to have my 3 imported here, I need to do import everything as 3 from 3 like this. And here vector takes capital letter. And now inside of that use frame, I'm going to have to modify the VUV scale to properly scale my UVs. So to do that, I need two things. I need to have the aspect ratio of the image, and I need to have the aspect ratio of the viewport, right? So those are two different things. This is the aspect ratio of the image, right? The width and the height. And this is the aspect ratio of the viewport, the width and the height. I need to know those two things to properly scale the UVs. So what I'm gonna have is a const image ratio and a const viewport ratio. But actually I'm gonna change the wording. I'm gonna call it scale ratio and aspect ratio. So the aspect ratio refers to the image and the scale ratio refers to the viewport, right? So it's a simple ratio, right? So scale X divided by scale Y. Simple as that. And for the aspect ratio of the image, it's going to be the width divided by the height. And let's remember the width and the height, they come from here, the texture image. So it's just going to be the width and the height of my image here. So now I have my two ratios that I can use to set my VUV scale. So I'm going to have that plain current material uniforms, but it's going to be the VUV scale dot value, and I can do a set to set a vector. On the X, I'm going to just set it at 1, and on the Y, this is where I'll change things. I'm going to do the aspect ratio divided by the scale ratio, something like that. So honestly, there would be a ton of different ways to scale your UVs. Like I looked online and there's like a million ways how people do it, but that's how I found for me the best way to do it, which is kind of an easy way. But just keep in mind there's 100 ways of doing this. And then after that, I'll grab my VUV scale that I now have access as a uniform here, uniform vec2 VUV scale. And I'm gonna modify my VUV here and I'm gonna multiply it by the VUV scale just to adjust the scaling of the UVs. So for that, I'm gonna do a bit like I did here, a duplicate, like a clone. I'm gonna have a vec2 UV is equal to VUV, and I'm gonna multiply it by the VUV scale. Let's just do it like that. See what we have. I'm gonna save. Let's try it. I'm gonna have a crazy screen size like this, and let's see if it still stretches, and it still stretches. So something is wrong here. Okay, so what's wrong is I actually did not use my UV here. So what I need to do is, instead of using the VUV that comes from the vertex, I'm gonna use my UV, which is like the scaled VUVs, right? Take that, put it here. Let's try this. I'm gonna scroll, and now I have my image that's not scaling anymore. But now there's another problem, right? Is it's zooming and it's sticking at the bottom, right? You're gonna see, if you look at the brush here, you're gonna see that it's zooming and it's cropping from the top and it's keeping the bottom position. So it's kind of, it had like a transform origin bottom, right? If I put it, for example, this aspect ratio, it looks much better because on mobile, it's kind of like the same aspect ratio of the image. But if I put it on desktop, now it's kind of, it goes from vertical to portrait into like horizontal or like landscape. So it's a bit weird. So how can we fix this? Well, we just need to adjust the VUVs. So once we understand this coordinate system, we'll understand a bit the magic numbers that I'll put in here, which is like a classic function or mathematical equation that I see used a lot inside of shaders to basically center the UVs. And to do that, all we have to do is do minus 0.5 on the UVs, and then we scale them. And after that, we do plus 0.5. And that way we are centering everything. It's kind of doing a transform origin center. All right, it's a bit of a trick, bit of a mathematical equation, but it's a bit less like magic numbers once we understand the coordinate system here. So I'm gonna save that and I'm gonna scroll this. And now you're gonna see that it's scrolling towards the center of the image, right? We can see the clouds, we see the bush, and you're gonna see if I zoom, both are disappearing. So it's clearly zooming towards the center, which is what I want. And now depending, of course, on the size of my window, it's gonna look better or worse because of the aspect ratio of my image. So yeah, that's basically it for this tutorial. We have a nice wave pattern, and if I scroll, it's killing the wave and it's scaling the image all the way to full screen. And even if I change the amplitude and my wavelength, it's gonna have the same result here. So yeah, that's basically the animation. I think it looks great. I think it's a funky animation that I could see inside of an awards winning website. So if you like the video, if you've learned something, leave a like, subscribe, and I'll see you in the next one.